Hello everyone, welcome back to my YouTube channel. In today's video, I'll be showing you a presentation that I created on the high-level system design for a video streaming service like YouTube. The interesting part, I made this entire presentation in under 30 minutes using Presentations.ai and ChatGPT. While I won't go into the exact steps in this video, if you are interested in learning how to create such presentations quickly and efficiently, let me know in the comments. I'll record a follow-up video explaining each step in detail. Now let's jump into the presentation. Hello everyone. Today I'll be walking you through the system design of a video streaming service, which is similar to YouTube. We'll be discussing about the high-level design, like covering all the major components of the architecture and explaining why certain technologies were chosen over others. So my name is Akshat and let's start this presentation. So in the index and introduction, we'll be like just an overview that we'll be covering about the client-side technologies, content delivery network, application layer technologies, database technologies, storage layer, video processing pipeline, streaming protocols, security protocols, load balancer, messaging and queuing system, analytics and monitoring, and the last, it's recommendation system. So let's start with client-side technologies, which are basically web and mobile. So we'll be using basically the tech stack HTML5, React for the web framework, and Swift or Kotlin for the mobile. So why these framework? Like these technologies basically provide a responsive and interactive user experience. React allows for fast rendering using a component-based approach, while Swift or Kotlin are the go-to languages for the native mobile apps, ensuring seamless performance on iOS and Android. Why not any other stack? So for that, like I would say, like older technologies like jQuery or Angular are not as efficient in handling complex state management, and frameworks like Flutter or React Native, while it is great for cross-platform apps, but it may not deliver the same native performance for heavy media application. Okay, for content delivery network, which is also called CDN. So we'll be using basically AWS CloudFront and Cloudflare. So why these? CDNs basically we use to reduce latency by caching content on the edge servers closer to users. This significantly improves the streaming performance. Also, AWS CloudFront is highly scalable and integrates well with other AWS services, while Cloudflare offers global reach and excellent DDoS protection. We'll make you understand about the DDoS later in the slide. So why not any other tech stack? So they basically like traditional web hosting or the private data centers would struggle with massive traffic and global reach required by a platform like YouTube. So CDNs basically optimize the content delivery, and this is a critical for like such a video heavy service. Okay, let's move to application layer technologies. So here we'll be using basically the Node.js for the API gateway and Docker for microservices. Okay, so why? Node.js provides non-blocking input output, and it is highly efficient for handling multiple concurrent requests, making it ideal for real-time application. Docker enables microservices architecture, allowing services to scale independently. Basically, it's a containerization benefits. Why not any other stack? So like Python or Ruby could also be used, but they are not as performant with input output heavy operations as Node.js. Monolithic architectures also are also less flexible and scalable, making microservices with a Docker a better choice for a service expecting high traffic. Database technologies. Okay, so basically we'll be using both like PostgreSQL for relational database and like for the user data, and MongoDB for the NoSQL for video metadata. So PostgreSQL is basically a strong relational database that ensures data consistency and supports complex queries. It is also perfect for managing user accounts, transactions, and subscriptions. Regarding MongoDB, it is better suited for flexible, unstructured data like video metadata and tags, which need much more like in terms of horizontal scaling. Why not any other tech stack? My preference are these because like the relational databases like MySQLs are less suitable for unstructured data, while MongoDB offers much better scalability for video metadata. Also for user data, NoSQL databases like Cassandra might not provide the necessary consistency and the transaction support. Okay, let's move to the storage layer. So in storage layer, we are basically using the AWS S3 for the object storage. Okay, why? Because S3 is basically ideal for storing large files like video content due to its durability, scalability, and low cost. It also integrates with other AWS services comfortably like CloudFront and Lambda, like enabling efficient CDN and processing. Why not other stack like let's say block storage? So block storage, which are like AWS EBS or local disk storage. These are less suitable because they don't scale as easily or provide redundancy at the same level as S3. So traditional databases are also inefficient for large blob like video files. Okay, so now let's go to the video encoding and transcoding. So basically we will be using FFmpeg here for the encoding. So FFmpeg is a powerful open source tool for encoding and transcoding video into multiple formats and bit rates. And we'll also be using the AWS Elastic Transcoder, which automates this process and scale with demand, ensuring that the videos are optimized for different devices and bandwidth. Why not any other tech stack? So basically, proprietary software can be expensive, like if we get it licensed, and those would be much more less flexible. And FFmpeg is an open source and it is completely widely used, so there are much more customer support for that. Like community is very strong. Yeah, let's move to the next slide. So the streaming protocols. So the streaming protocols here we are using HLS and Dash. Okay, so HLS is basically HTTPS live streaming, and Dash is basically dynamic adaptive streaming over HTTP. So HLS and Dash are basically widely supported streaming protocols that provide adaptive bitrate streaming, ensuring that users with different internet speeds also receive the like best possible quality we need. They all work by splitting video into small chunks, adjusting quality based on the user's connection. So there are other tech stacks also which are not preferred, which is like RTMP, which is real-time messaging protocol. It is outdated and less efficient for modern video delivery. Also, HLS and Dash are like more scalable and provide a better user experience across a wider range of devices. Now we'll be moving to the security protocols. So in security, we would start with SSL or TLS encryption, DDoS protection, and we'll be using AWS Shield for that. Okay. So SSL or TLS, basically they ensure the communication between clients and servers, preventing any kind of data breaches. AWS Shield also offers the DDoS protection at the network layer, ensuring that the platform remains available during malicious attacks. Why not any other tech stack? Again, like for alternative, like which are custom SSL setups, these are very hard to maintain, and also AWS Shield provides out of the box protection that scales completely with the application. Okay, so next we'll move to the load balancer. So here we'll be using the AWS ELB, which is Elastic Load Balancer, and it is best in itself. So why? Basically, as you can see, like AWS ELB, like it distributes traffic across multiple servers. It ensures that no single server becomes overwhelmed. It automatically scales with traffic and offers like multiple built-in health check-ins. Why not any other tech stack? Like there are alternatives like Nginx or HA proxy, and it can work, but it requires much more manual setup and scaling. ELB is also integrated with the AWS ecosystem, and it simplifies the setup and scaling process for a cloud-based infrastructure. Okay, let's move to the next slide, which is messaging and queuing systems. So in this, basically, we will be using AWS SQS, which is simple queue service. Why? Because SQS basically provides a fully managed queuing service that allows asynchronous message processing. It scales automatically and decouples video upload and processing tasks, and it also ensures that no process is blocked at all. Why not any other tech stack, which is like, let's say, Apache Kafka? So Apache Kafka is like, it is much more complex to set up and maintain, while SQS, it like offers simplicity with managed scaling, making like it is obviously like SQS is a better fit for video platform, because since the video platform needs rapid scaling and message delivery reliability. Okay, so the next slides come to analytics and monitoring tool. So here, we use the most widely used Prometheus for the metrics, Grafana for the visualization, and ELK stack for the logging. Okay, so Prometheus basically provides the real-time metrics, like it provides the metric collection and monitoring, while Grafana, it's used to visualize these metrics which are provided by the Prometheus in a specific dashboard for easy tracking of the system performance. ELK, which is Elasticsearch, Logstash, and Kibana, it offers robust log collection and analysis, which is essential for the troubleshooting. Why not any other tech stack? Alternative monitoring tools are we have like Datadog, which are effective, but it come with higher costs, and especially for the large scale system like YouTube. And Prometheus and Grafana are open source, and these are highly customizable, offering more control over system monitoring. Okay, so let's move to the next slide. Machine learning based recommendation system. Okay, so here we are using the TensorFlow, which is ML framework, and the Apache Spark for the data processing. Okay, now why? Basically, TensorFlow, it is a very powerful machine learning framework, and it is used to build recommendation models based on user behavior and video interactions. And Apache Spark basically processes large data set quickly and efficiently, which enables real-time recommendations. Like whenever you see the YouTube search button, like whatever kind of videos you search, then you automatically see kind of recommendations. So these are basically this part is utilized here. Why not any other tech stack? So there are alternatives like PyTorch, which could work, but TensorFlow has better support for like a production grade system. And Apache Hadoop also could be used for batch processing, but obviously it's like Spark is much more faster and better suited for the real-time analytics. So this was about the very high level design of the streaming service. If you have any queries or any questions, or you would like to dive deeper into any aspect of the design, feel free to ask. I'm happy to discuss further and address any feedback or suggestion. So thank you. Thank you all. And also, I want to give the credits to Presentations.ai, like using which I have created this complete PowerPoint. Thank you all. And that's the presentation. I was able to pull this together in just 30 minutes. 15 minutes to record the content, and the other 15 minutes to enter the ChatGPT prompts, then back to presentations.ai, and then do the fact checking, and that's it. So if you found the presentation useful and want to learn how I did this step by step, let me know in the comments. I'd be happy to create another video showing exactly how to use these tools to build your own professional presentations. Thank you for watching. See you next time.